I'm really sick and I'm trying to avoid throwing up as I film this, so please, please, please have mercy on me when you read this. There's no camera. Okay, here's the introduction. Purpose is just to find the mass of the black hole by calculating the orbit of a planet around it, and then using that mass to find the initial velocity a spaceship needs to escape the black hole from or orbit it, either or. Here are the fundamental principles. They're kind of the same things we've been doing for like the past couple weeks. It doesn't really matter. Here are the lab results. Those are what I got. Take a second to read them. Here are the initial conditions. So yeah, that's what it is. Here's the code I had for finding the mass, and with this code I found that result. And then here's for the part 2, here's the code for finding the velocity. Again, I found that result, those results with it. I have an orbit and a escape velocity listed, and okay, those are actually flipped. 1.6 should be the escape velocity, and 1.147 should be the orbit velocity. And then here's the mass of the black hole. Like here's the working glow script. It looks like it should. I found the mass of the black hole. What in the world? Here's the second part of the lab. The initial velocity is the spaceship part. Here are the initial conditions for that. G is always constant, and then the other stuff was just given to us. Here's the code for calculating the net force, and then using that to, once we have a model that calculates net force, we can just plug and play with velocities to figure out which one's right. And here's the results for the escape velocity. You can see the kind of tail on it. And then the simulation gets more accurate as delta t decreases because it's a symplectic calculation, and it kind of works like an integral. As delta t decreases, we get more accurate. What if we wanted to orbit? The initial velocity is slower than the escape velocity. That's kind of what the orbit looks like in that purple line. And again, I have the orbital speed listed earlier in the lab, so if you go look back at that. What does it mean? Yada, yada, yada. There's a question. Basically, the net force doesn't change a whole lot. It changes as you move around, because as it gets closer, the gravitational force increases, which increases the net force, and thus the parallel and perpendicular components. But the rate of change of the momentum changes a lot, going from positive to negative, and way positive to way negative. That's when it really changes a lot, and you can see that in the arrows. And that's it. Thank you. I'm really sick. Please, please, please go easy. I'm trying not to throw up.